When we graph rational functions, we're going to have two types of asymptotes. The first type is a vertical asymptote. Alright, so you can't graph where the function doesn't exist. Therefore, there's going to be a vertical asymptote for any x value that makes our denominator 0. And this is what we've kind of been working with already when we state those domain restrictions when we've simplified or solved rational equations. All right, the second type is going to be a horizontal asymptote. And with the horizontal asymptote, there are actually three different, let's say, restrictions or three different ways that you can have a horizontal asymptote. And this is our first way. If the degree in the numerator is equal to the degree of the denominator, then your horizontal asymptote is going to be y equals a over b. Now, a and b are your leading coefficients. So here's an example. If I had 2x squared minus 1 over, let's say 3x squared plus x minus 4, then since the degrees in the numerator and the denominator are both the same, they're both 2, then my asymptote, my horizontal asymptote, is going to be the coefficients of the numerator and denominator. So you're going to have y equals 2 over 3. So that's our first way we could have a horizontal asymptote. The other way is when the degree of the numerator is less than the degree of the denominator. And anytime this is the case, our asymptote is y equals 0. That's it. It doesn't matter the coefficients or anything else. If the degree in the numerator is less than the degree in the denominator, the horizontal asymptote is y equals 0. Alright, and our third type of horizontal asymptote comes from when the degree of the numerator is greater than the degree of the denominator. Now, this actually isn't a horizontal asymptote. This is where we would say that we don't have one, that there isn't a horizontal asymptote. So follow those three guidelines and you'll realize you either have the coefficients if the degrees are the same. If your denominator degree is greater, it's 0, y equals 0. And then if your numerator is greater, there isn't going to be one. Another restriction or characteristic that we have when we graph rational functions is that we can have a hole. So if I gave you the function 2x squared plus 2x all over x squared minus 1, just like when we simplified rational expressions, you need to factor first and simplify because this is where a hole is going to be created. So in my numerator, I have a DCF of 2x, and then I'm going to have x plus 1, not 11, 1. And my denominator is the difference of two squares. So now you can see that because we factored, we can simplify and we can cross this out. Now, if you can do this cross out like I just did with the x plus 1, that's where there's going to be a hole. So you're actually going to say, okay, we have a hole at the x value, negative 1. So that's why it's important when we simplified before, we look at the original. Before we cross things out, before we simplify, we state the restrictions. And now it's important to know why it's a restriction. It's not because it's an asymptote in this case. It's going to be because there's a hole, because we simplified, because we crossed it out. So if we went a little bit further, this right here would then simplify into 2x over x minus 1. And from the horizontal asymptotes that we just spoke about before, then you are going to have a horizontal asymptote at y equals 2 because our degree for the numerator and denominator were equal. They both were 1. And then if we went one step further in our final answer, we're going to consider our vertical asymptote and say, okay, well, x also can't be 1. So we have a hole at -1, we have a horizontal asymptote at 2, and then we have a vertical asymptote, which would be the x equals 1 in this case, at x equals 1. Alright, so let's look at this example. You have 2x plus 5 over x minus 1. So let's look at our vertical asymptote first. The vertical asymptote is whatever value for x is going to make our denominator 0. So that's kind of easy for us to pick out. So our asymptote is actually going to be where x can't be, which is that -1. Oh, I'm sorry, +1. Okay, so we're going to have a vertical asymptote at +1 right here. All right, now, there we go. Now we're going to move on to now our horizontal asymptote. So you're going to look and say, okay, do I have 1 degree that's bigger? Where is it? Or are they the same? And in this case, the degree on the numerator and denominator both are 1, so it's going to be a horizontal asymptote of y equals 2. So then I'm going to go up to 2, and here's my horizontal asymptote. Okay, so at this point we can take some values, we can substitute them in. Let's find our x and y intercepts then, if there are any. And if we were to do that, we're actually going to have a point, and I'll just let you know what that is since we finding our x and y intercepts are review. Let's see, we have one at 0, -5, 1, 2, 3, 4, 5, right here. And then we also have one at -2.5, so right here. So that is, those are our 2 intercepts. And then if you chose some more values and you plotted a few more, create an XY chart or use your calculator, then you'll see that your graph is actually going to go through those 2 points here, but then it's not going to touch those asymptotes, and it's going to do the same thing in that other quarter of our graph. So this is what that problem looks like. Let's look at another example. Alright, in our next example, we need to start by finding the vertical asymptotes, and to do that, I actually need to put my denominator in factored form. So if I did that, I'm going to have x plus 3 and x plus 2. So I did this so I can easily say, well, I'm going to have 2 vertical asymptotes. I'm going to have one at x equals -3 and one at x equals -2. Okay, now for a horizontal asymptote, there isn't going to be one because the degree of our numerator is greater than the degree in our denominator. And then if we were to plot some points, we would have a graph that roughly looks like this. It's actually going to come up and kind of plateau a little bit here. And then it's also, so this is our estimate, a sketch of this graph, if you will, but keep in mind I have 3 parts. I have one here, one in between my asymptotes, and one on the left as well. The only other example that I could show you is if I had a function that was like this. Alright, so now we have x minus 1 over x squared minus 4. The first thing I'm going to do to find my vertical asymptotes is I'm going to factor that bottom, and it's the difference of 2 squares. So I'm going to have x minus 2 and x plus 2, which means that I have an asymptote, a vertical asymptote, at x equals 2 and x equals -2. And then for my horizontal asymptote, this is the last example, the last type that we can see. Our degree is greater in the denominator which means that we have an asymptote of y equals 0. So our x-axis. Okay, so if I sketch this, I can use my calculator and plot points, and I would have this left side right here, excuse me, that right side, and then I'd have one also over here on this left side. Okay, now, here's the exception. This graph actually comes and it goes through just like this. So this is an exception of where our horizontal asymptotes, we are going to go through them sometimes. So if there's ever a middle part to the graph, it is allowed to go through like this one did. Vertical asymptotes, they are not. Notice how all those functions stay within our vertical asymptotes. So just know that horizontal asymptotes have a little bit of an exception.